Hello students, today we will discuss about solution of exercise 8.1 from the chapter Introduction of Trigonometry. Today we will continue our discussion of the solution of question number 7, 8, 9, 10 and 11. So let us start with question number 7. Question number 7 is, if cot theta is equal to 7 by 8, evaluate the value of 1 plus sin theta into 1 minus sin theta by 1 plus cos theta into 1 minus cos theta. Also find the value of cot square theta. So as you can see, the value of sin theta and cos theta is not given here. So I have to find the value of sin theta and cos theta. You know the formula of sin theta. Sin theta is opposite by hypotenuse, cos theta is adjacent by hypotenuse. If you look at the figure ABC where right angle at the point B, then this BC will be the opposite side, right, and this AB will be the adjacent side. That means to find the cos theta and sin theta, I have to find the length of hypotenuse also. Now given that cot theta is equal to 7 by 8, also cot theta is equal to adjacent by opposite. That means cot theta is equal to AB by BC, and AB and cot theta is also given as 7 by 8. So you can consider AB as 7k and BC as 8k. That's why BC is equal to 8k written over here and AB is equal to 7k. So by Pythagoras theorem, you can find what will be the length of this AC side. Okay, so let's check. Okay, so AC square will be BC square plus AB square. If you put the value of AB and BC, you will get 113k square. That means AC will be root under 113 into k. So the length of this side is 113k. So you get the length of hypotenuse. Therefore, sin theta will become side opposite to angle theta, okay, by hypotenuse. Okay, I got this value as root under 113k. So sin theta will be side opposite to theta, that means this one BC by hypotenuse AC. Okay, put the value of BC and AC, it will be 8k by root under 113k. So kk will be cancelled, it will be 8 by root under 113. Similarly, cos theta is side adjacent to theta by hypotenuse, that is AB by AC. So 7 by root under 113. Okay, so you got the value of sin theta and cos theta. In part 1, you have to find the value of this thing. Okay, so in place of sin theta and cos theta, put the value of sin theta and cos theta. So here I am putting the value of sin theta and cos theta. As you can see, if you do the LCM, the value of this whole expression will become 49 by 64. Okay, now in the second part you have to find the value of cot square theta. Okay, this notation means cot theta whole square. Okay, this notation means cot theta whole square. Okay, that means you have to put the value of cot theta, which is 7 by 8 and whole square. So the resulting value will be 49 by 64. Okay, so this is all about question number 7. Now question number 8. Question number 8 is, if 3 cot A is equal to 4, check whether 1 minus tan square A by 1 plus tan square A is equal to cos square A minus sin square A or not. Okay, this question is similar to the previous one. So from here you can write cot A is equal to 4 by 3, right? So this is a right angle triangle, A is the acute angle, this one is 90 degree. So you know that cot is adjacent by opposite. Okay, so you can write this one as AB by BC again. So you are considering AB as 4k, okay, AB as 4k and BC as 3k. So again by Pythagoras theorem you can find the value of AC. Okay, if you use Pythagoras theorem, the value of AC will become 5k. Okay, so this value will become 5k. Now in the left hand side you need the value of tan. Okay, you know that tan is the reciprocal of cot, right? Tan A is equal to 1 by cot A, reciprocal. That means if cot A is equals to 4 by 3, tan A will be 3 by 4, right? So in place of tan A, I am putting the value of 3 by 4. Now tan square A is given, that's why 3 by 4 whole square. If you do the calculation in the denominator and numerator, you will get the value as 7 by 25. Now for the right hand side, you need the value of cos square A and sin square A, that means cos A and sin A. Okay, so here the length of opposite side is given 3k, adjacent side is 4k, and you have evaluated the value of hypotenuse as 5k. Okay, that means sin A is equal to opposite by hypotenuse, that is BC by AC. So the value will be 3 by 5, right? Similarly, cos A is AB by AC, that is 4 by 5. Put the value in place of cos square A and sin square A. If you do the calculation, the value will be again 7 by 25. So for both the cases, for RHS and LHS, the value is 7 by 25. So you can write this is equal to this one. Okay, 1 minus tan square A by 1 plus tan square A is equal to cos square A minus sin square A. This expression is true. This is all about question number 8. Now question number 9. Question number 9 is in a right angle triangle ABC, right angle at the point B. Okay, tan A is given as 1 by root 3. Okay, this is similar. These questions are similar. Now tan A, if you look at the picture, this is the acute angle, so this is the opposite side and this is the adjacent side, and you know the formula tan A is opposite by adjacent, that is BC by AB. The value of tan A is also given as 1 by root 3. That's why I am considering BC as 1k, BC as 1k and AB as root 3k. Okay, so again by Pythagoras theorem I can find the value of AC. Okay, so by using Pythagoras theorem, the value of AC will become 2k. So this length is 2k. Okay, now what you have to find? In the first part, you have to find sin A cos C plus cos A sin C. Okay, sin A cos C, cos A sin C, and next one is cos A cos C minus sin A sin C. Okay, so if you look at the first part and second part, you can see here the acute angle is A and here the acute angle is C. Again here A, here C, here A, here C. That means you have to find sin A cos A sin C and cos C. Okay, you have to find these 4 values: sin A, cos A. That means first of all, in the first case you have to take A as acute angle and you have to find sin A cos A. Then again you have to take C as acute angle and you have to find sin C cos C. Okay, so you got the value of 3 sides. So now we will find the value of sin A, cos A, sin C and cos C. So you get the hypotenuse as 2k. So for sin A and cos A, you are taking A as acute angle. Whenever A is acute angle, this one is opposite side, okay, and this one is adjacent side. So sin A is opposite by hypotenuse, that is BC by AC. That's why the value will be 1k by 2k or 1 by 2. Similarly, cos A will be adjacent by hypotenuse. Okay, adjacent by hypotenuse, that means AB by AC. So it will be root 3 by 2. So you get the value of cos A and cos C. Now when you are calculating, this is cos A, cos C, when you are calculating sin C and cos C, you have to take C as acute angle. Okay, this C is acute angle. Then this side will become opposite. Okay, this one will become opposite side and this one will become adjacent side. So sin C, the formula will be same, opposite by hypotenuse. Now the opposite side is AB, right? So AB by hypotenuse will remain same, AB by AC. So it will be root 3 by 2. Similarly, cos A is equal to adjacent by hypotenuse, that is BC by AC is equal to half. Okay. So you got the 4 values of sin A, cos A, sin C and cos C. Just put it in this expression in the first part, sin A cos C plus cos A sin C, put the value, you will get the value as 1. And for this expression, if you put the value, as you can see, it will be root 3 by 4 minus root 3 by 4, the value will become 0. Okay, in this way you have to solve this question. Okay, now question 10. Here in PQR right angle at the point Q, PR this side plus QR this side is equal to 25. PR plus QR is equal to 25. And PQ length is given as 5 cm. You have to find sin P, cos P and tan P. Okay, you have taken P as acute angle, only side of one side is given, length of one side is given. That means you have to find the length of other two sides. So I am considering this QR as x. Okay, from here you can write, you are considering QR as x. From this equation you can write PR is equal to 25 minus x. Why? Because PR is equal to 25 minus QR. Right? PR is equal to 25 minus QR, and you have considered QR as x. So it will become 25 minus x. Done? Now you will use simple Pythagoras theorem. You know that hypotenuse square is equal to base square plus perpendicular square, that is PR square is equal to QR square plus PQ square. In place of PR, PQ and OQ, okay, I think it will be PQ square plus, it will be QR square, okay. Or RQ square, okay, RQ square. In place here, put the value 25 minus x square is equal to 5 square plus x square. Okay, so if you do the square on the both side, you will get this equation. If you solve this equation, you will get the value of x. The value of x will become 12. That means this QR will be 12. Now if this is 12, the value of this side will become 13. Right, 25 minus 12, that is 13. So you got the length of PQ, QR and PR. Okay, so now you have to find sin P. This is the acute angle. That means sin P will be 12 by 13. Cos P will be 5 by 13. And tan P will be 12 by 5. Okay. Now we will discuss about question number 11. It states whether the following are true or false. Verify your answer. The value of tan A is always less than 1. This first one is false statement. Okay, let me erase these things. This one is false statement. Why? Because you know the formula of tan A. Tan A is opposite side by adjacent side. Okay, and there is many cases. If I draw this right angle triangle, okay, here this adjacent side, if this is the acute angle, this adjacent side is more than this opposite side. But if I draw this type of right angle triangle, right, and this is acute angle, then this opposite side will be more than this adjacent side. So for some cases you can say that opposite side is more than adjacent side, and if opposite is more than adjacent, then opposite by adjacent will be more than 1. Okay, so you can say that the value of tan A can be greater than 1. So it is not always less than 1, right? That's why the given statement is false. Okay, so first one becomes false. Now next one, sec A is equal to 12 by 5. You know the formula of sec A. Sec A is hypotenuse by adjacent side. For a right angle triangle, you know that this hypotenuse is always more than the perpendicular and the base. Okay, and here the value, in the value, this 12 is more than 5, right? So that's why by the definition, since hypotenuse is more than adjacent, so this statement will be true. Okay, because it satisfies the rule of right angle triangle. Now third one, cos A is abbreviation used for the cosine of angle A. This is totally wrong. Why? Because cos A is abbreviation of cosine A. Okay, it is cosine of A. So let's check the solution. It is false because cos A is used for cosine of angle A, not cosine of angle A. Cosine of angle A represent this cosine of angle A represent cosec A, not cos A. Okay, it is cosec A. Now fourth one, cot A is product of cot into A. This is totally wrong, totally false. Why? Because cot A is a trigonometric ratio whose definition is adjacent of the acute angle, adjacent side of the acute angle by opposite side of the acute angle, right? So this is a ratio of two sides of a right angle triangle. It is a trigonometric ratio. This is not a product. That's why it is a false. So it was false. This one was true. This one was false. This is also false. Now sin theta is equal to 4/3 for some value, for some angle theta. Now if you draw a right angle triangle, sin theta, and suppose this is a acute angle. Okay, sin theta is opposite by hypotenuse, so you can write this is opposite as 4k and this hypotenuse as 3k. Now what I said, in a right angle triangle, hypotenuse will be always more than perpendicular and base. Okay, but here as you can see, the perpendicular value is more than the hypotenuse value. That's why this is not possible. So this will be false. Okay, so you know that hypotenuse is always greater than the opposite side. So this is false. In this way you have to justify which one is true, which one is false. All the reasons are given here, okay, in this slide. So this is all about exercise 8.1. That's all for today. Thank you.